This is the homework help video from Monday, May 7th for all classes, 10-5 practice. We're stepping this up to 8th grade level by working on probability of dependent events as well as independent events. This first problem we're going to do, problem 6, begins by saying an experiment consists of rolling a fair number cube and tossing a fair coin. So these are independent events because the toss of the coin, the result of that toss, does not depend on what happens when we roll the dice. So these are independent events, so the formula for independent events, probability of A and B equals the probability of A times the probability of B. So we'll figure out the probability of each independent event and then multiply those probabilities together. So we have to find the probability of getting a 2 or 3 on the number cube. The number cube has sample space 1 through 6. So the favorable outcomes, there are 2 favorable outcomes over the total possible outcomes, 6, and then if you divide by 2 to simplify that fraction, you get 1/3. So the probability of a 2 or 3 equals 1/3, and then we want to flip heads on the dime, so we know the probability of heads is 1/2. One favorable outcome out of 2 possible outcomes, heads or tails. So the probability of heads is 1/2, and then the probability of 2 or 3 on the number cube and then heads on the dime would be equal to these 2 probabilities multiplied together. Multiplying fractions, that's no problem. Top times top, 1 times 1 is 1. Bottom times bottom, 3 times 2 is 6. So the answer is 1/6. These next problems are dependent events. Well, let's read the scenario first. A box contains 3 red marbles, 6 blue marbles, and 1 white marble. The marbles are selected at random, one at a time, and are not replaced. So since they're not replaced, the second time we pick a marble, the total number of marbles is different and the number of each of certain colors has decreased. So the first one, probability of blue and red, is equal to the probability of blue times the probability of red after blue, meaning the probability of pulling a red marble after a blue marble has already been pulled. So the probability of blue is straightforward enough. There are 6 blue marbles out of how many total? 10. 3, 6, 3 and 6 and 9, and 1 is 10. 6 over 10, and then we divide by 2 to simplify that. We get 3/5. Probability of red after blue, after we pull that blue marble, how many red marbles remain? Well, we didn't pull a red marble, so there's still 3 red marbles. But how many total marbles are there now? There are no longer 10, now there are 9. And then if we divide by 3, get 1/3. And then you multiply those 2 fractions together. 3/5 times 1/3, top times top, 3 times 1 is 3. Bottom times bottom, 5 times 3 is 15. Divide by 3 to simplify. You get 1/5. Or we could have cross-simplified right here, dividing by a common factor of 3. And we get 1/5. I'm speeding up a little bit because I want to get this last problem in. Probability of red and then blue. Probability of red the first time would be 3/10, 3 over 10. Probability of red the second time, now there's 1 less red marble, so there are 2 red marbles, 2 over, and 1 less marble total, so 2/9. Probability of blue, well, there's still 6 blue marbles, but now there are 8 marbles total because we've already pulled 2 marbles. We multiply those together. I'm going to do some cross-simplifying here before I multiply. Common factor there would be 3, so dividing by 3 I get 1 here and 3 here. Common factor here would be 2. 2 divided by 2 is 1. 10 divided by 2 is 5. And a common factor here would be 3, 1 and 2. And a common factor here would be 2, 1 and 4. So top times top, 1 times 1 times 1 is 1. Bottom times bottom, 5 times 1 times 4 is 20. 1/20. If that cross simplification was too fast, just do top times top times top, bottom times bottom times bottom, and then simplify. You'll get a big fraction you have to simplify. If you simplify it correctly, you'll still get 1/20. Okay, I hope that helped. I'll see you in the morning.